So it will be, the work will be the product of the magnitude, force, displacement times the cosine of the angle between the two vectors. In other words, it's going to be the dot product, because that's what the dot product is. All right, so the dot product is a natural way to calculate work. So let's write a few words toward that end. So the short end of it is the work done by a force F, and F, the force is a vector, to move an object or to a displacement d, like so, and again, both of them are vectors, is given by, and here's the expression that you can expect. It will be W for work equal the dot product F dot D, which is the magnitude of F times the magnitude of D times cosine theta. Straightforward. And the reason behind it is this: if you have a force F like so that causes a displacement in this direction D like so, and this is the angle theta, then in order to calculate the portion of the force that coincide with the displacement F, we take the projection of F. Okay, so this portion is really the projection of F on D, and then we multiply these two to get the work. Okay, so, and you, of course, you know what is the scalar projection. I mean, we take the magnitude of the projection and we take the magnitude of D and we multiply it out. Okay, and that's how we prove this. Make sense? So we can write here W equals the magnitude of the projection of F on D times the magnitude of D. Okay, and the projection, the magnitude of the projection is the scalar projection, so this will be comp F on D times the magnitude of D, and of course comp F of D is F cosine theta times D. Okay, and this is of course the dot product. Actually, let me write one more statement here, one more line.
Wait, so you're right from the projection of F on D to opposite?
The projection, the magnitude of the projection is the scalar. Okay, it says, you see the magnitude here. So we can write it as F D like so, cosine theta, and this is equal to the F dot D. So what I did, I proved. So what I need to write here, it's a proof of this theorem. So I just proved the theorem, and we are ready to do an example. So the example, again, it's kind of straightforward. For example, you have given the force and displacement illustrated below, find the corresponding work for the given data. So what is the given data, or what is the illustration? Well, the force going to equal, the magnitude of the force equals 70 Newton. Remember what's Newton, right? It's the force that required to accelerate 1 kilogram mass to an acceleration of 1 meter per second squared. So the story goes like this: you have some kind of hand cart on wheels, like so, and this is, you apply force in this direction. So this is F, and you move the cart in this direction, and the angle in between is, let's make it 30 degrees. So this is the displacement vector, and you pull the cart, or you push the cart. The way I drew it is you pull the cart, and perhaps you have a baby here or something. Perhaps this is a crib or something like that, and you have a screaming baby here, and you want to run as fast as possible to deliver it back to his mother, because you are the grandfather who pulling the. Something like that. Anyway, so and this is the force. The displacement, the magnitude of the displacement is 100 meter. So we make it all nice and easy. And theta, of course, is given as 30 degrees. And we need to solve this thing. The solution itself is very quick, right? I think we can squeeze the solution on this page. I'll undo this plate, thank you. So the dot product, W equal F dot D, but we don't have the vectors. All we have is the magnitude. So we'll use the other expression, the one on the right. So it will be the magnitude of F times the magnitude of D times the cosine. And therefore it will be 70 times 100 times cosine of pi of yeah, it's square root of 3 over 3. You got it.
Over 2.
Square root of 3 over 2. So square root of 3 over 2, and that will be 3,500 times square root of 3, right? Mm-hmm. And what are the units? Joules. Force, Newton multiplied by meters give you joule. All right, so this was it, and we are ready to move on.